Welcome to Khetz tutorials, and this is a continuation of probability. In this video, I want to talk about selections. And in this portion, we're basically talking about having a limited number of places to fill. So limited number of, let's say, spaces. In a previous video, I did talk about a 4-digit code. So we have digits 0 to 9. But if you're required to make a 4-digit code, then you basically have only 4 spaces, but 10 digits to choose from. Now, if no repetitions are allowed, then you basically have 10 options over there. After picking one, then you basically have one less option. Picking one, you have one less option, and something like that. So this can be computed in this way. That would be the total number of arrangements that you can make with no repetitions. Now, this can also be written in another format, taking n to be the number of options that you have, and r as the number of spaces that you have available. You can now see that the answer to this is if you multiply the top, or if you basically multiply everything that I wrote, this is the answer that you expect. Now, with this new notation, or with these new variables, you can now have a general form that you can use when you have limited space. So maybe when you have, or always when you basically have less spaces and actually more options, or more options than there are spaces. Now, in that case, then you basically write your answer as n factorial, where n is the number of options, divided by n subtract the number of spaces which are available r factorial. Now, in this case, you can write this, since we have 4 spaces and we have 10 digits to choose from, the options are 10, and the spaces, we basically have 4 spaces. And you can write this out as 10 factorial divided by, first compute the value in the bracket, which is 6. So that would be 10 factorial divided by 6 factorial, and that gives you the exact same answer. So this is how you deal with cases where you have less spaces, right, but have more options, so more options than there are spaces. And you basically just do this if the order is basically fixed. And what I mean by when the order is fixed will basically be apparent in a moment. So let's go to an example. We actually have 2 examples where the order is fixed, and I'll do one last example where we can do whatever we like with the order of the elements. So let's say this is example 1. In this example, it says there are 12 contestants in a race. How many different ways can first, second, and third place be arranged? As you can see, we basically are interested in first, second, and third, right? So we can't put just about anyone over there. We can only put the person who came in first place, and only put the person who came in just like that. So the order is fixed, right? So since the order is fixed, we don't have to worry about anything else. We just have to use the general form as we found it. So as you can see, we have 12 contestants, which means we have more people than there are places in this set, or on the podium, right? So we have 12 options. Any of the 12 people can be first, second, or third. And we only have 3 spaces. So that is how you'd compute this. The result will be 12 factorial divided by 9 factorial after computing everything in the bracket. And the answer that you expect to get from that is 1320, right? So that is how you deal with such a case where you have a fixed order, which is first, second, and third. And in the next example, we also do have a fixed order where we talk about, so let's just read the problem statement. Local running club is holding a fundraising lottery. So it says 4 numbers are to be drawn, so 4 numbers, 2, 3, 4, from a possible 10 numbers. So just from that line, we know that we actually have more options than there are spaces. So when we have 4 spaces, and we have 10 numbers involved, right? In order for a ticket to win, the numbers on the lottery ticket must be in the same order that they were drawn. How many different winning arrangements are possible? Now from this, the order is fixed. We're told that these numbers can't be anything. So let's say the draw actually produces 1, 2, 3, 4. If you have a ticket which has 4, 3, 2, 1, then you basically can't win. Even though you have the exact same numbers, this order has to be preserved. Now that the order is fixed, or we know that our numbers have to be in a certain order, there's nothing that we have to worry about. Just use the general formula as it is. And the number of options is 10. Then there are 4 spaces. And the result will be 10 factorial divided by 6 factorial, which is exactly the same as the example which I made up there. And that should give you this. And that is your answer. Now, in the last example, there's a change and we have to deal with that in a different way. And here's where the change actually comes from. It says an airline had 12 seats left on a flight when a party of 16 applied for seats. In how many ways could 12 people be selected from 16 to fill the flight? Right? So let's read that again. We have 12 seats, so 12 seats, 1 up to 12, and we have 16 people, so 16 options. And these people have to fill up 12 seats. So now one would just basically just use the formula, but it doesn't just end there. Nothing was said about the order that these people can sit. So one person can start over there, and another person can sit next to that person. Or this person can start over there, and this person can, any person can start, and any person can fill any position, right? So what we have to do to cover up for this possibility is that we compute as we previously did right here, which is that we have 16 options, 16 people. And those people should basically subtract the possible seats or the possible spaces, but we also multiply by the possible arrangements or the possible ways that these people can actually be placed on the seats. So nothing was said about how these people should be placed like in the previous 2 examples. In this example, we know that we wanted to place the first, second, and third, and those are specific people who actually got those positions. So these positions are fixed. In the second example, we basically talked about the winning ticket having the same order as the order they were drawn. So if the draw, as I showed, if the draw produced this order and the ticket actually had this order, even though the numbers are exactly the same, you wouldn't win, right? Which means the order in this case is fixed. But now what we want to do is we just want to place these people on the flight. We just want to place the people on the seats. Nothing is said about the order, so we have to account for the different order that these people can be seated. So you still do your general formula over there, but just make sure that you multiply by the factorial of the spaces to cover up for the different options or the different ways that these people can be seated. And if you do that, then you expect to get the following as your answer. So that is it in this video. I just wanted to make you aware of the types of questions which are related to selections. And I believe this is the last video in the probability section. And I hope the video was of value. I hope you found something helpful in the video. If you like the video, just give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.